Let's do this, guys. This is the last lesson in Unit 8, and we're looking at the law of cosines. So if we looked at this triangle at the top, let's try to figure out why it's not possible to solve for x here using the law of sines, what we did last time. If you remember, you start law of sines problems by looking for angle and side pairs within your triangle. I would probably start by scribbling out A, B, and C because I don't like looking at that. So if I looked at this triangle, I see we only are given one angle, and that angle goes with the side across from it, which is x in this case. So there's a pair, an angle and side pair that's both labeled. Then I look at the other numbers. Those two, they're not a pair. They're both side lengths. So maybe I just looked at 42. 42 goes with this angle C right here. 21 goes with this angle B right here. I can't find either of those angles thinking 180, and I don't have them. So for the sake of showing you why law of sines won't work here, let me just say that I'm going to circle that pair. It would work out the same way if I circled the other pair, but watch what this looks like. If I set up law of sines, it'd be like sine 39 over x equals sine of C, I don't have it, over 42. Now, notice that I used two variables, x and c. If you ever do that, it's a really sad day. You're never going to be able to solve this. Cannot use two variables. You can only use one. So I would just be stuck. This is why we need law of cosines, people. We need a different tool for solving for this x. SOHCAHTOA wouldn't work. Pythagorean theorem wouldn't work. Got to have the law of cosines. So here it is. It's horrendous looking. It's so many letters. You guys, you don't have to memorize any of this, let alone 3 lines of this. It's ridiculous. Cross off the bottom too. The only reason I even put all 3 on here is because if you Googled law of cosines, you might see any one of those. It might look like that on your formula sheet. All this is different variations of A's, B's, and C's, the sides and angles of the triangle. If you can make sense of just that first line of it, you're going to be fine. We'll never look at the rest of it. I'll always just look at that first line. So it's all the same thing. Don't be deceived by that. But first line only. Remember from law of sines, last lesson, lowercase letters represent sides and capital letters represent angles of your triangle. So keep that in mind. Same thing applies here. If I were to look at this first line here, notice all of these letters, except for that end one, are sides because they're lowercase. And notice there's only one little piece on the left-hand side. It's squared, but one letter goes by itself right there. And that's a side because it's a lowercase letter. Notice that that letter, little a, that's the same letter that's all the way on the other end of the formula, except that's big A, so that's the angle there. Those guys match. And what that tells you, if it's little a, big A, those are a pair on either end of your formula. So here's where the difference lies between law of sines and law of cosines. Law of sines, you needed 2 angle and side pairs. For law of cosines, you're only going to need 1. So we'll say 1 pair. And it's really important to note that your pair, your little a, your big A, are on the ends of the formula. The in-between stuff, that's just little b, little c. Those are the other 2 sides of your triangle. All right, I know it's kind of a lot to look at. I also like to point out, look at the bottom one. You'd see it a lot better on that because it's a squared plus b squared equals c squared. It's just really like Pythagorean theorem plus a little extra stuff. Can you even imagine the person who discovered this? Way smarter than all of us put together. All right, watch how I set this up. So I'm going to use law of cosines to solve for x in this top triangle here, where law of sines did not work. So right away, the first thing I did was I circled this angle and side pair. So that's your one pair that you have labeled in this triangle. That's your little a and your big A. The first thing that I do is I set up the outsides of the formula, the little a, big A. So that's the side of my pair, which is x. And you're going to square it. All the way on the other end is cosine of the angle in the pair. So 39 So I set up the outsides, then I go in and I fill in the middle stuff, the B's and the C's. Those are just the other two sides of your triangle, 21 and 42. Doesn't matter which one's which. So I'm going to go like 21 squared plus 42 squared. Then it's minus 2, and I'll use parentheses, 2 times those same two pieces there, 21 and 42. So it's really not that bad. I promise with just even a little bit of practice, you'll get the hang of it. Most of it's just calculator work. So you might want to do this with me. You have two situations. Either the X is over here or the X is over here. It's on one end or the other. If the X is the side, it's on the left-hand side by itself, this is the easier situation. I'm just solving for this because all I have to do is put the entire right-hand side into my calculator at once. Like just type it exactly like it looks. Minus 2, 21, 42, cosine 39. Don't hit equals until the very end. So that's not too bad. If your calculator is different than mine, just ask me when we're working on stuff in class and I'd be happy to show you kind of how to punch it in. But notice that that's not the answer. That equals x squared. So I have to do one more thing. I have to square root to get rid of that x squared, or that squared. So x is completely by itself. So watch what I'm going to do in my calculator. I'm going to do second x squared to get the square root. I don't like to round. I want a perfect answer. So here's where I'm going to do that second parentheses to tell my calculator, take the square root of the answer that I just had in there. That's the perfect answer. Rounded to the nearest tenth would be 28.9. Wasn't that fun? All right, on the back. So this is the last lesson in the unit. So thinking ahead to the test now. On the test, oh, that's my battery there. I'm going to plug in. All right, plugged in. On the test, I will tell you like, hey, these problems are the law problems, but you're not going to be told which law to use. You'll have to decide, do I do law of cosines or law of sines? Here's how you tell. It's how many pairs are labeled on the picture. Law of sines, remember this from last time, needs 2 pairs of angle and sides labeled on your picture to be able to solve. If it doesn't have 2 pairs, you're going to use 2 variables and you can't solve that. Okay, law of sines or cosines is just 1 pair. Sines is 2, cosines is 1. Okay, I would always check for law of sines first. Like, oh, can I get 2 pairs? Because to be honest, law of sines is easier than cosines, but both are manageable. I want to find angle L on this picture. Nearest tenth of a degree, for me, I don't love looking at those letters. It doesn't matter though. I cross them out and I just call that X. I have no idea why I like to do that, but I do. Then I look for pairs. Okay, that's going to help me to decide which law to use. So X is the only angle that's labeled. That's what I'm trying to find. That goes with side 10. If you don't have any other angles, like you're not going to have another pair that exists without using a different variable. So I only have 1 pair here. I'm going to have to use law of cosines. Sines won't work. So I take my pair, that's my little a and my big A. That's the ends of the formula. So little a is the side of your pair. Big A is the angle of your pair, which in this case is X. So I'm going to put cosine X. I always set up the outsides first. The B and the C in the middle, that's just the other 2 sides. Doesn't matter which one's which. So we'll say 12 squared plus 8 squared minus 2 times those pieces again, cosine X. Okay, this one's not as easy. So like I said, X is either here or here. When it's over here, it's the angle. You cannot just plug everything in your calculator at the same time. You have to solve this thing for X. You've got to like undo the order of operations. I'll kind of show you in class like why you have to do it like this. But basically you find 3 numbers first. So you can do this 10 squared over here. Obviously that's 100. You can square these 2 guys and add them together. So that's 208. This part always weirds people out. I know it's kind of hard to remember. And then you get this number. Don't subtract yet. You get this number, 2 times 12 times 8, 192, cosine x. The biggest mistake people will make, and I will show you off to the side like why it doesn't work, and I'll show you in class, but you can't subtract these two from here. Cosine x is like connected to this guy. These are multiplied. You'll have to undo that. So right here, this next step, if you're like solving for x, you have to subtract the 208 over, which that like gets people, but we'll make a big deal out of it. So that's gone, and you're left with negative 192 cosine x. Then again, those are being multiplied, so you have to divide by negative 192. It's probably going to be a hideous number. Oh, it's not that bad. That equals, guys, cosine x. Now, anytime you're solving for an angle, you're always going to end with inverse sine, inverse cosine. Cosine negative 1 here, and then you put that decimal in. Oh, shoot. Move the equal sign. So I'm going to do second cosine of that decimal. That was pretty easy to type. Otherwise, I would have done the second parentheses. To the nearest tenth, that's 55.8 degrees. Okay, lots of practice with the calculator work coming your way with this stuff. I know it's kind of a lot. Last example, they want me to find all the missing pieces. Angles to the nearest degree, that's whole number. Sides to the nearest hundredth, 2 decimal places. I got to use my laws, find my pairs, figure out what I have to find first. I'll keep the A, B, and C here just for the sake of filling in the missing pieces, but I noticed right off the bat that there's only one angle. So I'm going to figure out what side goes with that. So this side. I'm just going to call it X. So I'm going to make those guys a pair. I do not want to use any other variables here. I only want to use one if I want something I can solve. So there's only one pair I can circle, so that tells me, shoot, I need to do law of cosines. There's one pair. So I'm going to solve for this x value first using the law of cosines. Let's see if we can get it. There it is. Here's my pair. That's how I start setting up this formula. So side of the pair, which is x. Angle of the pair, which is 61. 16 and 5 are your B and C. They fill in the middle. Not equals. The struggle is real. Ignore that. All right. Well, it's going to drive me nuts. There we go. I want you guys to see if you can get the answer there, and then we'll continue forward with the next part. Okay, so if you didn't get this, the answer for x is 14.26 to the nearest hundredth. So that's side AB. Cool. Put that on the picture. So now I have like a complete pair, basically. So I need to find another piece. I could make another pair because I can throw in a variable now since I don't have x anymore. I know that's 14.26. So maybe I'll just solve for like angle B here. And I'll make those guys a pair. So I'm going to get angle B, and I'm going to set up law of sines because I now have 2 pairs. So I'm going to do like sine 61 over 14.26 equals sine of B over 5. So see if you can get B there doing what you know about law of sines, and then we'll go ahead and fill in that last angle. Okay, so if you didn't get this, or make sure you have it written down, when you solve this, the measure of angle B should be 18 degrees. So get that on there. From there, it's easy to just get angle A. All you have to do, since you have 2 angles, you're just going to want to do 180 minus 18 minus 61, and that'll get you your measure of angle A, and that's it.